first step. When you get your quiz tomorrow, what is the very first thing you should do?
Write down that.
All students take calculus. Thank you. This is all you should have to write down. All students take calculus. Okay? All students take calculus. What this chart tells you, it tells you where your trig functions are positive. In quadrant 1, everything is positive. All positive. In quadrant 2, S represents sine. So sine, and you need to remember that its inverse tags along with it. If sine is positive, then cosecant's positive. The inverse always tags along with it, okay? T represents tangent and cotangent, and C represents cosine and secant. So all students tells you where your answer is positive. Okay, let's use 150 here. Okay, what quadrant is 150 in? It's in the second, right? And I know that maybe we haven't spent as much time, but remember, this is how your quadrants look, right? It goes 0, 90, 180, 270, 360, okay? So 150 is in quadrant 2. So what is the only trig function positive in quadrant 2? Not sin, sine, and cosecant. And what's that tell you about the rest? They're all negative. I immediately know that those are all negative, okay? If I threw 300 degrees at you, what quadrant is 300 degrees in? Quadrant 4. What is the only thing positive in quadrant 4? Cosine and? So do you see how I fill those out? These are our positives, so what's that tell me about the rest? Negative, 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 negative. So this should be the very first thing you do, because what happens if you forget to put your pluses and minuses? How many are you going to miss on every row? You're going to miss 4. You're going to tell me all, like I'll have people turn in their quiz and every answer is positive. Well, if you look at it, most of the time you have 4 negatives and only 2 positives. So if you forget to do all students take calculus, you're going to miss 4 answers. To pass your quiz tomorrow, you can only miss 6 out of 24. You could only miss 6. And so if you miss these 2, you're done already. And you still got 2 rows to go, okay? Do all students take calculus? Everybody understand how I come up with how pluses and minuses work? So it tells you where they're positive, okay? So you figure out what quadrant you're in. Shoot, we'll do one more. 225 is in what quadrant? In quadrant 3. 180 to 270, quadrant 3. What's the only thing positive? Tangent. So I'd go plus, tangent and cotangent. And what's that mean about everything else? Negative. What is the only type of problem that I could give you where you don't have to worry about missing anything?
0 to 90 degrees.
0 to 90 degrees. If I give you an answer if I give you a problem like 60 degrees, 60 degrees is in what quadrant? 1. And what do we know about every trig function in quadrant 1? All positive. They're all positive. Okay? Make sense? All right, number 2. What would be the next thing you do? You've already determined all your signs. What would we do next? Yes? Reference angles. I think this is kind of messing you up a little bit. All right, by definition, what is a reference angle? Anything
between the x-axis, right?
Yes, and what measures does it have to be between?
60, 45, or
0 and 90. So a reference angle can be between 0 and 90, right? 0 and 90 degrees. Now, when you're doing your timed quiz, what does your reference angles always have to be? They either have to be a 30, a 45, or a 60. Okay? When you're doing your timed quiz, I can't give you a problem in which your reference angle is 32 degrees. We can't find that answer unless we have a calculator. We don't get to use calculators on the quiz. So when you're doing these problems, your reference angles always have to be 30, 60, or 45. It's got to be one of those. Okay? Now, I don't know if you need to do this. Yesterday, I wrote down this formula on how to find your reference angles. We talked about that any angle in quadrant 1 is its own reference angle. right? What's the reference angle of 60 degrees? 60 degrees. What's the reference angle of 10 degrees? 10 degrees, okay? What do I do in quadrant 2 to find my reference angle?
180.
180 minus. And what do we do in quadrant 3?
Theta minus 180.
Theta minus 180. Do you notice I only use 180s? I never use 90 and I never use 270, okay? If you used 90, that means you drew your triangle like that. That doesn't make sense, right? Okay, we always draw our triangles to the x-axis. So that's why we always use 180 when we're doing our reference angles. What's our last one?
Minus
360 minus theta.
Good. Okay, so I don't know if you need to know this or not. Some of you might just visually be able to think about it. Like right here. Some of you might just like, well, 150 is right here. I know that my reference angle is this angle. Okay, the angle between the x-axis and the hypotenuse. That's always my reference angle. If this is 150, what does that have to be?
30.
30, right? It has to be 30, right? What's 150 plus 30? 180, okay? So this is 30. What do you think the reference angle of 300 is?
60.
60.
Oh my God.
What do you think the reference angle of 225 is?
45.
And hint, anytime I give you a problem that has a 5 in it at the end, your reference angle is always 45. Always. You don't even have to calculate it. You just know it's 45 degrees. Okay? Make sense?
Yes, sir.
Okay. So you can do this. You could be a visual person. Just know that your answer better be 30, 45, or 60 when you do these problems. Okay? Sometimes I'll give you 60 degrees. Well, it's already ready to go. You know your reference angle. Okay? All right. After you find your reference angle, what do we do now? Probably the most important thing. Draw your triangles. And this is something that maybe you have to write out a bunch so that until you have it memorized. I always put 30 down below. I always put 60 up top. I just do the same thing every time. What happens is I notice people will flip these, but then they don't flip the side measures. Always just put 30 down below. What is always opposite of 30?
1.
And then opposite of 60?
Square root 3.
Square root of 3, and the hypotenuse?
2.
2. You just got to memorize those. You just have to know those ratios. They never change. Okay, 45. 1 root 2. These two triangles allow you to solve this problem now. If we didn't have these triangles, we couldn't do it. And again, you don't get to use a calculator, so we have to know these ratios. That's why I can only give you reference angles of 30, 45, and 60. I can't give you I can't ask you to find 100 degrees because your reference angle is 10, and we can't do that without a calculator. All right, what's our last step? SOHCAHTOA. Okay. So when you get your quiz, the very first thing you should do tomorrow is generate these 4 things. Because number one, I know a lot of people say, okay, I get it, but what happens if you don't list it, then people don't do it. They'll just tell me every answer is positive, and they're going to miss 4 times. They're going to miss 16 out of 24 questions. Okay, so do this. This reminds you to find reference angles. You definitely need this written down, and then SOHCAHTOA to help you know your ratios. Let's finish this chart out. So we've already calculated the sines. We found our reference angle, 30 degrees. Now we just go to our triangle and we go to work. We know that sine is opposite over hypotenuse. What would be the opposite of 30? What side measures opposite? 1. And what is the hypotenuse? 2. Now, some people I saw yesterday, they would just go through and they'd say, okay, for 30 degrees, they'd put an O, and then they would put an A, and they would put an H. And that kind of helped them a little bit label what their triangles were. So they know that sine is O over H, 1 over 2. So what's cosecant? What would cosecant be then? 2 over 1. They're just reciprocals, right? Okay. What would cosine be? AH, adjacent over hypotenuse, So root 3 over 2. Now, no matter what, you know you have to do some rationalizing. I mean, we just have to be able to rationalize. We know that secant is 2 over root 3. What is that in proper form? You should start to be able to do this in your head. 2 root 3 over 3. And let me come off to the side and just show you it. I don't want to do this on every single problem, but we can't have a radical in denominator. So all I do is multiply top and bottom by root 3. So I get 2 root 3 over 3. Okay? What would tangent be? No. Or well, what would be the ratio? So this would be opposite over adjacent. So it's 1 over root 3, and then what is that as your final answer? Root 3 over 3. Now, I talked about this yesterday. Which one do you want to flip? Do you want to flip the 1 over root 3, or do we want to flip the root 3 over 3? Flip the first one, because then you don't have to rationalize it. If you flip the second one, now you get 3 over root 3, and now you got to go through and do all this work. And look what I get. I get the exact same answer. I get root 3. So I always write down my original problem, and then that's the one I flip when I do my radicals. It saves time. It's a little trick. Okay? All right, so that kind of makes sense. So let's finish up with this 300 real quick. So for 300 degrees, we found all of our sines. We found the reference angle to be 60 degrees. So I go to 60 degrees, and now I just do the exact same thing again. Okay, so 60, I want to know sine. Now, you do have to change these, right? So 60, this would be my O, this would be my adjacent, and this would be my hypotenuse. Okay, so just relabel those if you need to see those. All right, let's go to work. Sine. Opposite over hypotenuse, root 3 over 2. So, cosecant is 2 over root 3, which is 2 root 3 over 3. I want you to take a minute and look at some of your work that we just did. Don't answers just repeat. Do you notice that? Wait a minute, we just had a 2 root 3 over 3. We just had a root 3 over 2. You'll start to notice, wait, there's patterns to things. And that's how people get these quizzes done in 30 seconds. They understand there's patterns to everything. Okay, let's finish it out and we'll talk about it. What would cosine be? Adjacent over hypotenuse. 1 over 2, so secant, 2 over 1. Okay, what would tangent be? Opposite over adjacent, so root 3 over 1. You don't have to show the ones, I'm just showing you so you can see your ratio. There we go. Does anybody see a pattern? Like, how could you maybe really bust this out quick?
Anything that has a degree of 60 is going to be the same answer no matter what, except for the sines.
I'm not
Like
catching
if you have one that's regular, just like 60.
Yeah.
That's going to be the same as.
Oh yeah. Okay, I see what you're saying. That works. Anybody else see a shortcut? Look at this. Look at the sine of 30. Look at the answers, 1/2 and 2 over 1. Look at the cosine of 60, 1/2, 2 over 1. These are called cofunctions. So I have my sine of 30, and what's 30 plus 60 equal to? 90. That's why they're called cofunctions. If I know sine of 30, I know cosine of 60. If I know the cosine of, or the sine of 60, I know the cosine of 30. They go hand in hand. Okay, so what a lot of people do is they just find the answers for 30 degrees and they automatically know the answers for 60. They know that these two answers go here and those two answers go there. They just flip them. So like for them, they're like, I just memorized what 30 is. And I have some people that just like, I just memorized the row of 30 degrees because now I know the answers for 60 degrees. And look what happens to tangents. They just flip. This goes there and that goes there. So that's a little trick that some people take advantage of. Okay? Here's the last trick. I guess we better finish up with this one. 45 degrees. What do you know about sine and cosine of 45 degrees? They're the same. Because what is sine of 45? 1 over root 2. What's cosine of 45? 1 over root 2. So a lot of people know that once I know sine, I know cosines, because they're exactly the same answers. You have a 1 and a 1. What is 1 over root 2 in proper form?
2 over 2.
And what would then cosecant be? Which one do you want to flip?
Or 2 over 1.
It'd be root 2. So I automatically know these two answers. I don't even have to think about it. I know they're identical. Sine and cosine of 45s are always the same. And then lastly, what's tangent of 45? 1 over 1. Okay? So little tricks that you'll maybe pick up as you go, and there'll be just some of you that do each row independently, and that's fine too. Okay? Does this help clear up a little bit? So we won't work this out, but what if I gave you 120 degrees? What quadrant is 120 in? Second quadrant. What's the only thing positive in quadrant 2? So I would go plus, plus, minus, 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 minus. Right? What is the reference angle for 120 degrees? 60. Now, do you see a shortcut here to find all your answers? Don't we already know all the answers for 60 degrees? You already found them. 300 and 120 are the same answers. The only thing that's different are the signs. That's why we do all students take calculus. Okay? So once you know one, you probably know multiple answers. You don't have to redo everything. You already know 60 and 60. Okay? There's another little shortcut to finish this up. Yes?
So how do you know, like, how do you figure out, oh, I just realized.
Okay, look at that. I answered it without even doing nothing.
I was just gonna ask, how do you figure out if it's 30 or 60, and then I realized that it's the quadrant thing.
Okay, yes.
My question is just about writing on the 300 with the 60 degree reference angle
Yeah.
and tangent. Is that square root 2 over 1?
Right here, right here. No, right here.
Right there. Is it
That's
2?
root 3 over.
Is that root 3?
Yeah. Okay, the only other thing that I want to go over with you, and I'm just going to give you a chance to finish this worksheet up, okay? But I'm going to go back and add some of the problems that I threw out, okay? Don't scribble them out. I want to go back, and I'll just maybe do like number 11 with you, but I'm going to have you go back and do 11, 13, 14, and 16. And then I want you to finish up these problems on the back if you haven't done so. Like I wanted you to yesterday to do A through D, so now do E, F, and G. Okay, just finish those up. So basically, you're just finishing up this worksheet today. Okay, but let me do number 11 with you guys.
Do you also do 16 on the homework?
16.
Yeah. It's root 7, 3. And it's,
Oh yeah, we'll talk about it.
We'll talk about it. Thank you.
Actually, that is not as bad as you think. But we'll definitely talk about it. Okay, here we go. Let me do number 11 with you guys. And this is the last kind of thing, and then I'll just give you a chance to finish stuff up. What was the point that you were given for number 11?
Negative 5, 6.
Negative 5, 6?
Yeah.
Okay, let me get... All right, let's do this one. We'll work it out, and then the rest of the hour, just finish up stuff. Okay, here we go. So on this problem, did you notice that the problems that we just did, I gave you an angle measure. Well, now I'm giving you a point. I'm giving you a point, not an angle measure. So I'm going to come over here, and we'll work it out. So here we go. So for number 11, you were given the point negative 5 and 6. So the very first thing you want to do is just sketch this. You're going to go negative 5, positive 6. There we go. So that is your first thing. Negative 5, positive 6. This first number means left or right. This second number means up or down, right? So negative 5, positive 6. What quadrant are we sitting in? The second quadrant. And what's the only trig function positive in quadrant 2? Sine. And when we work this out, you're going to see that it works out. All right, here we go. Where is theta? Is it angle 1 or angle 2? It's always 2. Doesn't it have to be inside the triangle? So I'm going to put theta right here. All right, how are we going to find the hypotenuse? Pythagorean theorem. Here we go. So I get -5 squared plus 6 squared. Really watch your negatives. When you square something, your answer will always be positive. Here we go. So I get -5 squared is 25. 6 squared is 36. What is 25 plus 36?
61.
And what is the square root of 61?
Decimal.
I don't want decimals, so we just leave it as root 61. There is no perfect square that goes into 61. It doesn't break down. This is what I was telling you about trig. Very seldom do your radicals break down, but we are going to have to do some rationalizing. Okay, so all I did is that squared plus that squared equals that, and then square root it. All right, we're ready to go to work. Here we go. What would sine be? What would sine be? Opposite over hypotenuse. So it'd be 6 over root 61. And what is that in proper form now?
61 over.
It would be 6 root 61 over 61. You just move that radical to the top, right? You just multiply top and bottom by root 61. Now again, which one do you want to flip? The first one. Let's flip the first answer, and then I don't have to do any work. It's root 61 over 6. Okay, writing this down pays off. Okay, moving on. What would cosine be now? Adjacent over hypotenuse. -5 over, okay, -5 over root 61. What would that be in proper form now? -5 root 61 over 61. You just move the radical to the top, right? All right, and again, which one do we want to flip? The first one, negative root 61 over 5. Okay, tangent, opposite over adjacent. Opposite over adjacent. So negative 6 over 5, so cotangent negative 5 over 6. Now, look at our diagrams. We said the only thing positive in quadrant 2 is sine. Here's why. Notice your opposite and your hypotenuse are positive in quadrant 2. That is why sine is positive. And if you notice, tangent and cotangent, this -5 is the adjacent leg, and notice that it's negative. So that's why cosine, secant, tangent, cotangent is negative, because all of those ratios require the adjacent leg, right? Adjacent, adjacent. So that's why sine is positive in quadrant 2. It's just not made up. There's a reason. The opposite and the hypotenuse is positive. Okay? Make sense? Now we had a question, and I don't want to work it all the way out, but I know they throw a problem like this as a radical. Here's all you do. Well, let's graph this. This is positive root 3 and this is positive 2. So again, make your scale generous. Positive root 3, 2. Now, I think what's messing you up is like, well, how do I do the Pythagorean theorem with the radical? Actually, it works out really nice. What is the square root of 3 squared?
3.
It's 3. The square root of 3 squared is just 3. That radical disappears. And what's 2 squared?
4.
And what's 3 plus 4?
7.
So I get c squared equals 7. So c is equal to root 7. Now I just go to work like I normally would do. I know that sine is 2 over root 7. 2 root 7 over 7. I know that cosine is root 3 over root 7. I got to rationalize now, right? Multiply top and bottom by root 7. Yes?
Are we doing 4, 5, or 6? Those are ones.
No, I didn't. I'm not worried about the reference angles one, so you can leave those empty.
Okay.
Does that help with the radicals? So you see that when you square a radical, that radical disappears. Okay? So let's do a recap here. So,
Are we turning this in?
no, that was practice for you. I threw out 4, 5, 6 yesterday. You don't have to worry about those. Don't worry about those. So on 1 through 10, you're just finding your reference angles. You're doing this right here. Now here, since it's not a time quiz, your answers could be 15 degrees. It could be 20 degrees, okay? I don't want you to, some people in their mind think reference angles can only be 30, 45, and 60. That's only true when we're taking our time quizzes, okay? I would like you now to try, finish out that chart. Do 11 through 16. I wanted you to do 12 and 15 yesterday. No radicals in those answers, but the rest of these, you're gonna get radicals. So finish out 11 through 16 for me, okay? Backside, yesterday I wanted you to do A through D. Today, just finish it up. Just do E, F, and G, okay? This is what your quiz is on tomorrow. That's the backside. And if you finish up early, like when you guys get to the backside, take a minute and see if you can rewrite these steps down again. Just keep writing them out and keep writing them out until you got it. If you do that, you will do fine on the quiz. I will throw out your lowest quiz of the semester because we're going to have so many of them. Hopefully not, but planning on it. But I won't do it till semester.
Did you say if we do good on our SAT, also throw out another quiz too, or a test?
Oh, the ISAT? The ISAT, I will drop your lowest test.
So we could get a test and a quiz all?
Lowest test. Or you could get a, yes, you could get a test and a quiz dropped. On your ISATs, if you get proficient, I will drop your lowest test. Yeah, I haven't decided yet. Sophomores, you just might have to get the deal next year.
Yeah, after you retire?
Well, but there's other teachers, they're gonna do the same thing. We all do the same
You
thing.
should just give them like a really hard test.
We all do the same thing.
You should just let us take the ISAT.
I,
Are they physically
You
not
really
allowed
do
to?
want to take
no,
the ISAT?
not anymore. You used to take it. So, half hour or so, finish up your worksheet. If you have questions, that skill drill is just, the first section is working with radicals, like breaking down radicals and so forth. Not bad.
Hey, so this is where I get stuck. Is the
Square root of 20?
No, the 088. I don't know how to.
Well,
Like,
beta,
how do you usually work?
well, what quadrant are you, what number are you working on? 13, which is 2, 4?
Yeah.
So,
It's in the all or.
yeah, so all of them are positive. That means, because your picture kind of looks like this, doesn't it?
It's just whichever one's touching.
And that, yes, that's your
So
beta.
then that would mean.
So this would be your
this is
opposite.
hypotenuse.
Yep, and adjacent. Now root 20 can break down. 4 times 5 is 2 root 5.
No, that's what
Yes, yeah, you gotta break them down.
So if they can't be broken down.
Yes.
You know what I realized though?
Alright.
For the, like, on 11 through 16, on 11 through 16,
Yeah.
even if you're not paying attention to like what quadrant your things in, they're automatically just gonna be negative anyway when you work it out. is what I'm saying.
Well,
In my STEM at least.
like some people, they don't draw their diagrams right. They just do all students take calculus, so they know, like, let's say problem 15's in quadrant 3, they already know that tangent is positive and everything else is negative. So this all students take calculus catches a lot of mistakes if you make them.
No, I got it.
Well, I don't want decimals.
I know, but that's not decimal.
Well, it's because it sets at 0. Oh, yeah, because, well, that's because when you draw your diagram, so when you draw, so that should be negative though, too, because you're going negative and down. Or unless you just graphed it wrong. If it was -4, -3 is what you should have.
Oh, it's positive.
So that means that your answer should be over here. Or wait, +4, -3, it should be right here.
But I did all my math, I just have to.
Yeah, yeah, that's good. Well, all you gotta do is, you know, that's in quadrant 4, right? So the only thing positive in quadrant 4 are those two, and everything else is negative. So you can catch it with all students take calculus. Yeah.
And then, 215, that's gonna be a 45, right? Because I have
Yes,
5 and I have to the
yep,
top.
exactly.
And then after I finish, I figured out down because I forgot, I was charging my AirPods this morning and I forgot to put it down there. So since this one broke down, this one broke down, I don't have that yet, how do I do
Yep.
that?
So you just multiply top and bottom by root 5.
By root
Yeah, they don't
five.
care about the 2. So it'd just be 2 root 5 over 10. Because if you multiply top and bottom by root 5, you get 2 root 5, and root 5 times root 5 is 5, and 5 times 2 is 10. So you get 2 root 5 over 10. Yeah. Now can you reduce the 2 and the 10?
Yeah.
1 and
5 over.
or 1 and 5. There you go, that's your answer.
So like this one, if you multiply, would be
So you would multiply top
4 root 5.
5 over 10. Because, we'll write root 5 on top and bottom. Let's see. So I get 4 root 5 on the top. Well, what's root 5 times root 5? Which is, and what's 5 times 2? So that's why it's a 10. Now always reduce if you can. Yep. Again, no decimals on any answers. Theta is always between the x-axis and the y-axis. So theta is right there. And root 20 breaks down. Break that down.
And it's tangent, cotangent.
Yeah.
Cosine.
Let me stop this.